When people stand inside certain cathedrals for the first time, there is often a moment of silence that comes naturally. Not because of religious obligation, but because the human mind struggles to immediately understand what it is seeing. Vast stone ceilings rise so high that they disappear into shadow. Walls seem impossibly thin for the weight they carry, and delicate details carved into heartstone appear as refined as lace. These buildings do not feel like ordinary constructions. They feel more like something that should not exist, at least not according to what most people believe about the technological abilities of the medieval world. This feeling is the starting point of a mystery that has fascinated architects, engineers, historians, and casual visitors alike. How were these cathedrals built, and why do they appear so technologically impossible even by modern standards? 2. Understand this sense of impossibility. It is important to remember how most people imagine the Middle Ages. Popular culture often presents medieval society as crude, slow, and intellectually limited, a time when science was underdeveloped. Technology was primitive. People imagined simple tools, poor understanding of physics, and a general lack of precision. In this mental picture, it seems absurd that the same era could produce buildings that rival or even surpass modern construction in complexity, durability, and aesthetic harmony. Yet many cathedrals constructed between the 11th and 16th centuries still stand today, some after surviving wars, earthquakes, fires, and centuries of environmental stress. Their survival alone challenges the assumption that they were built with inferior knowledge or methods. The scale of these structures is often the first thing that feels impossible. Cathedrals like Notre Dame, Chartres, Cologne, Milan, and Westminster Abbey are not merely large, they are colossal. Massive stone towers rise higher than many modern buildings, and interior spaces stretch longer than football fields while maintaining an airy lightness that seems contradictory to the weight of the materials involved. Stone is heavy, rigid, and unforgiving, yet medieval builders shaped it into soaring arches and thin walls, pierced by enormous stained glass windows. From a modern engineering perspective, stone structures of such height and openness appear risky, even dangerous. Without steel reinforcement or advanced calculations, the fact that these buildings were constructed centuries before modern engineering theory makes them seem almost unbelievable. Another reason cathedrals appear technologically impossible is the level of precision visible throughout their design. Walls align perfectly, arches meet at exact angles, and symmetrical layouts extend across vast distances. This precision suggests careful planning, advanced measurement techniques, and a deep understanding of geometry. However, medieval builders did not have access to computers, laser levels, or modern surveying instruments. They relied on basic tools such as ropes, compasses, plumbobs, and wooden measuring rods. Despite this, the accuracy achieved rivals that of modern construction. This contradiction between simple tools and complex results raises an obvious question. How did they achieve such consistency and perfection? Light is another element that contributes to the sense of impossibility. Gothic cathedrals, in particular, are designed to flood their interiors with colored light through massive stained glass windows. In some cases, entire walls seem to dissolve into glass, leaving only slender stone frameworks to hold everything together. From a structural point of view, walls are supposed to carry weight, yet in these buildings, walls appear to do almost nothing. Instead, weight is redirected through arches, ribs, and external supports in ways that seem almost magical. For people unfamiliar with structural engineering, this creates the illusion that the building is defying gravity, standing not because of solid mass, but because of some hidden knowledge or lost technology. The time required to build these cathedrals adds another layer to the mystery. Many of them took decades or even centuries to complete, and entire generations of workers labored on a single building, often without seeing its completion. This long timeline suggests careful planning far beyond short-term thinking. Builders had to design structures that would remain stable not just for years, but for centuries, even while incomplete. Portions of cathedrals stood exposed to the elements for decades, yet they did not collapse or deform. This implies a level of foresight and confidence in the underlying design that challenges the idea of medieval builders as merely experimental or primitive. Materials also play a crucial role in the perception of impossibility. Stone, wood, lead, and glass were the primary materials used, yet they were manipulated with extraordinary sophistication. Stone blocks, weighing several tons, were cut with remarkable accuracy and fitted together, so tightly that mortar lines are sometimes barely visible. Wooden roof structures spanned enormous distances without sagging. Lead roofing systems protected interiors from water for centuries. Stained glass, fragile by nature, was assembled into vast windows that survived storms and temperature changes. Achieving this level of material performance requires deep empirical knowledge, careful selection, and refined craftsmanship, none of which fit neatly into the stereotype of medieval technology. The absence of detailed written records explaining exactly how these cathedrals were built further fuels the mystery. While some sketches, contracts, and notes survive, they rarely provide step-by-step instructions or theoretical explanations. Much of the knowledge was transmitted orally through guilds and apprenticeship systems. This loss of explicit documentation creates the impression that essential techniques have disappeared, leading some to speculate about lost technologies or forgotten sciences. While historians caution against exaggerated claims, it is undeniable that certain construction methods are still not fully understood in practical detail, even if their principles are known. Another factor that makes cathedrals appear technologically impossible is the aesthetic harmony achieved across immense complexity. These buildings are not only structurally sound, they are beautiful. Proportions feel balanced, decorations feel purposeful, and every element seems integrated into a unified whole. This combination of engineering and art suggests that builders were not merely solving technical problems, but also pursuing philosophical and symbolic goals. Geometry was not just a tool for stability, it was a language through which builders expressed ideas about order, harmony, and the cosmos. Such abstract thinking, embedded into physical structures on a monumental scale, challenges the modern tendency to separate art from engineering. Modern engineers often express admiration and sometimes discomfort when studying these cathedrals. Computer simulations show that some structures operate very close to their theoretical limits of stability. Small deviations or failures in construction could have led to collapse, yet the buildings stand. This raises questions about how medieval builders tested their designs and how they gained confidence in methods that lacked formal mathematical proofs. It suggests that their understanding of forces, stress, and balance was deeply intuitive, built through generations of observation, experimentation, and correction rather than abstract theory. A sense of technological impossibility is also amplified by compiled comparison with modern construction practices. Today, large buildings rely heavily on steel frames, reinforced concrete, and advanced materials. Construction sites are filled with cranes, heavy machinery, and digital tools. And people learn that cathedrals were built without any of these, relying almost entirely on human and animal labor. The achievement feels even more extraordinary. The idea that thousands of tons of stone could be lifted, aligned, and secured using wooden machines and manual coordination stretches the imagination, even for those familiar with basic physics. Finally, cathedrals appear technologically impossible because they challenge modern assumptions about progress. There is an unspoken belief that technology advances in a straight line, with each generation surpassing the last. Medieval cathedrals disrupt this narrative. They suggest that knowledge can be gained, lost, refined, and transformed rather than simply accumulated. They remind us that sophisticated solutions can emerge from limited resources, and that human creativity is not dependent solely on advanced machines. In this sense, cathedrals are not just architectural achievements, they are reminders that our understanding of history, technology, and human capability is often incomplete. This sense of mystery, AWS, and contradiction is why cathedrals continue to fascinate the modern world. They stand at the intersection of faith, art, science, and human ambition, inviting us to question what we think we know about the past. As we move deeper into their structure, methods, and design principles, it becomes clear that their apparent impossibility is not the result of magic or lost civilizations, but of a form of intelligence that operated differently from our own. Understanding this intelligence requires looking beyond modern assumptions and appreciating the depth of knowledge embedded in stone, glass, and space itself. As one begins to look more closely at the physical form of these cathedrals, the feeling of technological impossibility becomes even stronger. The visual language of cathedral architecture appears deliberately designed to challenge gravity itself. Arches stretch upward instead of pressing downward. Ceilings float above vast open spaces, and walls seem almost secondary to light and air. This is not accidental beauty. It is the result of a structural system that was radically different from anything that came before it. Earlier buildings relied on thick, heavy walls to support weight, creating dark, enclosed interiors. Cathedrals, especially those built in the Gothic style, reversed this logic. Instead of resisting gravity with mass, they redirected forces with geometry. To modernize, this looks like advanced engineering disguised as art, achieved at a time when formal engineering science supposedly did not exist. One of the most striking features contributing to this perception is the extreme height of cathedral interiors. Some vaulted ceilings rise higher than modern 10-story buildings, yet they are supported by slender columns that seem too thin for the load they carry. This creates a visual contradiction. Heavy stone structures that feel light, open, and almost skeletal. The explanation lies in the careful use of arches and vaults. But understanding this intellectually does not fully remove the sense of wonder. Even today, when architects deliberately design tall stone structures, they often rely on hidden steel reinforcement to ensure safety. Medieval cathedrals expose their structure openly, leaving no visible modern support, which makes their stability appear almost miraculous. The pointed arch plays a crucial role in this illusion of impossibility. Unlike the rounded arches used in earlier Roman architecture, pointed arches distribute weight more efficiently, downward rather than outward. This allows builders to construct higher openings with less lateral pressure on the walls. While the concept may sound simple when explained, its large-scale implementation across an entire building requires extraordinary precision. If the angles were even slightly incorrect, forces would push outward and cause collapse. The fact that medieval builders applied this principle consistently across massive structures suggests a deep, practical understanding of structural behavior, even if it was not expressed through mathematical formulas. Rib ribbed vaults add another layer of complexity. These intersecting stone ribs form the skeleton of the ceiling, carrying weight to specific points rather than spreading it evenly across the entire surface. Between these ribs, lighter stone panels fill the spaces, reducing overall weight. Visually, this creates intricate patterns that draw the eye upward, enhancing the sense of height and movement. Structurally, it allows ceilings to span larger areas with less material. To modern observers, the combination of structural efficiency and decorative complexity seems advanced beyond what should have been possible with medieval tools and knowledge. Perhaps the most iconic feature, contributing to the perception of technological impossibility, is the flying buttress. From the outside, these arched supports appear almost counterintuitive, as if pieces of the building have been pulled away and reattached externally. Their purpose is to absorb the outward thrust generated by high vaults and redirect it safely to the ground. This externalization of structural support allows interior walls to be thinner and filled with windows. To someone unfamiliar with structural mechanics, flying buttresses look like artistic flourishes rather than essential engineering elements. The idea that medieval builders understood how to move forces outside the building, rather than simply adding more mass inside, feels surprisingly modern. The placement and size of stained glass windows intensify this sense of impossibility. In some cathedrals, windows occupy such a large portion of the wall surface that it seems the building should collapse under its own weight. Glass is fragile, and stone frames around it appear too delicate to hold massive structures together. Yet these windows have survived for centuries, enduring storms, temperature changes, and even partial destruction from wars. The success of these designs indicates careful calculations of load paths and stress distribution. Even if those calculations were not written down in mathematical form, light itself becomes a structural and symbolic element within the cathedral. Sunlight pours through colored glass, transforming heavy stone interiors into luminous spaces that feel almost weightless. This effect reinforces the illusion that the building is not entirely bound by physical laws. From a psychological perspective, light reduces the perception of mass and solidity, making stone feel less heavy and space feel larger. Medieval builders understood this effect intuitively and used it deliberately, blurring the line between engineering necessity and spiritual experience. Another reason these structures feel technologically impossible is the uniformity achieved across vast dimensions. Columns align perfectly over long distances, vaults repeat with remarkable consistency, and decorative elements follow strict proportional systems, maintaining this level of uniformity without standardized industrial production or modern quality. Control seems improbable. Each stone was cut by hand, each measurement taken manually, yet the final result appears almost machine. This suggests that builders relied on modular systems and geometric rules that allowed them to reproduce complex forms reliably. Even with human labor alone, the structural daring of cathedrals is further highlighted by the fact that some of them experienced partial collapses during construction. Vaults fell, towers cracked, and walls failed. Instead of abandoning these projects, builders analyzed the failures and adapted their designs. Reinforcements were added, proportions adjusted, and new solutions developed. This process of learning through failure resembles modern engineering practices more than the stereotypical image of medieval trial and error. The willingness to push limits, observe outcomes, and refine methods contributed to structures that grew more ambitious over time. A combination of extreme height, minimal material, and open interior space creates an effect that still challenges modern builders. Even with today's technology, constructing a massive stone building with such slender supports would be considered risky and expensive. Modern architecture often prioritizes efficiency and safety margins, whereas cathedrals appear to operate close to their structural limits. This closeness to failure, paradoxically, is part of what makes them feel alive and dynamic rather than static and heavy. They appear frozen in a moment of tension between collapse and stability, which adds to their aura of impossibility. What deepens the mystery is that these architectural solutions were not isolated experiments. Similar techniques appeared across Europe, adapted to local materials and conditions, but based on shared principles. This suggests a widespread transmission of knowledge that functioned effectively without centralized institutions or formal education systems. Master builders traveled between regions, apprentices learned by doing, and ideas evolved through practice rather than theory. To modern minds accustomed to written manuals and formal training, this invisible network of knowledge feels elusive and almost mythical. The visual impact of cathedral architecture also plays a role in why it feels technologically impossible. Human perception struggles to scale. When details remain fine and delicate at enormous sizes, the brain experiences a kind of cognitive dissonance. We expect large objects to be crude and small objects to be refined. Yet cathedrals combine monumental scale with intricate detail. Stone carvings high above the ground were crafted with care, even though they were barely visible to viewers below. This suggests a mindset focused not only on human perception, but on symbolic completeness, further reinforcing the idea that these structures were built according to principles beyond practical necessity. By examining these architectural features closely, it becomes clear that the sense of technological impossibility does not come from ignorance ignorance of physics, but from mastery of it in a form unfamiliar to the modern world. Medieval builders did not separate structure, beauty, and meaning. They unified them. The result is architecture that feels advanced, not because it uses modern technology, but because it uses human understanding to its fullest extent. As we continue to explore how these buildings were actually constructed, the mystery deepens, shifting from the question of whether they could be built to how such knowledge was developed, preserved, and applied with such consistency and confidence. Attention shifts from what these cathedrals look like to how they were actually built. The sense of technological impossibility becomes even stronger. The medieval world lacked engines, electricity, hydraulic cranes, steel cables, and modern transport systems. There were no digital blueprints, no stress testing software, and no standardized materials. Yet despite these limitations, builders managed to quarry, transport, lift, and assemble enormous quantities of stone with astonishing accuracy. Understanding this process forces us to confront an uncomfortable truth. Medieval construction methods were far more advanced and organized than we often assume.